Okay, so now we're going to look at how to calculate the present value of an annuity due. Remember, these are a series of equal amounts of payments, either to be withdrawn or received at equal intervals, and they occur at the beginning of the period. So we have to have that additional payment in there. So this is what it looks like. So the rent's at the beginning of the period rather than at the end of the period. In an ordinary annuity, we've got it at the end of the period. So the interest starts accumulating immediately with the present value of an annuity due. So let's take a look at our illustration here. Space Odyssey Incorporated, they rent a communication satellite for 4 years. Annual rental payments are $4.8 million made at the beginning of each year. So the relevant annual interest rate is 5%. We can calculate the present value of the rental obligations. Now, what they've done here is taken the present value of an ordinary annuity table. From the present value of an ordinary annuity table, they've found the factor, multiplied it by 1 plus the interest rate. Now, you actually do have a table, though, in your book. Let's take a look at that table right now. So we do have a present value of an annuity due table, and our payments, so this was 4 years at 5%, 4 payments, 5% is 3.72325 right here. Where did I go here? 4.54, whoops, 37, oh, sorry, right there, right above it. 3.72325 right there. And it's 3.7235 right here. Now you could use the previous table if you wanted to, the ordinary annuity table, and then you would do what they did in the book. Here's the previous table. 4 payments at 5% is 3.54595, and multiply that by 1. I'll get back to the book here where they have this. Multiply that by 1.05. But you have the in the book there is a table for this particular problem. So let's take an example. So here we've got Jamie won $4 million in the state lottery. So she's going to be paid $200,000 at the beginning of each year. Remember the previous example, she was paid at the end of each year. How much has she actually won? Okay, so let's look at Jamie's situation here. So we've got 4 million, so 200,000. Get to our slide here. So we've got 200,000 that was won, 20 years, and 8%. So let's find the factor, 20 years at 8%. Here's 20 periods. We're going to turn the page. Back here. So 20 years at 8%, and the factor is the present value factor, 10.6036, right here, 10.6036. That's our factor that we're going to use. Going to multiply 200,000 to get, let's see how much we've got. So 2,120,720,000. Not 4 million like they said, but this comes out to significantly less than that. So 200,000, there's the factor right there. 2,120,720. Okay. All right, so let's look at a couple of other examples here that we're given. Assume you receive a statement from MasterCard with a balance due of $528.77. You can pay it off in 12 equal monthly payments of $50 each, with the first payment being due 1 month from now. What rate of interest would you be paying? So here's some, this is trying to figure out what the interest rate is. And in this case, so we have to use that formula. 528.77 equals $50. Divide, and we'll, to get our present value factor. So we're going to divide the 528.77 by 50 to get a present value factor of 10.575. Okay, so this is, first payment is due 1 month from now. So this would be an ordinary annuity, right? OA. So we'd look at the ordinary annuity table. And as they mentioned here, so let's pull up the ordinary annuity table to find this interest rate. Oh, I don't think, yeah, they've got, we won't have this interest rate on our table. So if we refer to table 6-4, reading across the 12 period row, 10.575 is in the 2% column. So, and this is a monthly rate. So let's take a look here at table 6-4 and find that 10.57534. So if we've got 12 periods, oh, right here, the very first one, 10.57534. Now these are 12 equal monthly payments. So this, for each month, it's 2%. So the nominal interest rate is 24%. The effective interest rate, which is a little bit different, is 26.82413%, or 1 plus a, this is a kind of a supplement here, this equation down here. So the effective rate is a little bit higher than that, but the actual annual interest rate would be 24% on that MasterCard. So now we've got Norm and Jackie. They've saved $36,000 to finance their daughter's college education. They deposited the money in Bloomington Savings and Loan. It earns 4% interest compounded semi-annually. What equal amounts can their daughter withdraw at the end of every 6 months during her 4 college years without exhausting the funds? So if we look at the equation here, we're going to use that same, the present value of an ordinary annuity equals rents times the present value factor of an ordinary annuity. So we know what so we can look for the 4% and 8 periods. Let's take a peek at that. So we've got present value of an ordinary annuity. It's in the 4%, right? 4% column. Oh, I'm sorry. Yeah, 4% semi-annually every 6 months. Twice times 4, 7.32. I'm looking in the wrong spot here. Present value. Hold on a minute. Where are they getting their 7.3248? Okay, so this is a really good example of a mistake that's oftentimes made, and I made it as well. So I took the 12, let's see, let me write these factors down. So we've got 4% interest, and this is annual interest, and we have 4 years. Well, this is twice a year, so we've got 8 periods. I forgot to divide this by 2 and look in the 2% column. So there's a really good example of missing that, and I had mentioned that earlier that a lot of people miss that. I just did. So we've got 8 periods at 2%, so the factor is 7.32548. Back on here. 7.32548, and then they solved for R. So they took the 36,000 divided by that factor. She can withdraw $4,914.35 every 6 months until that $36,000 is exhausted. Okay, so that concludes looking through these the calculations for these different problems. The last couple pieces that we're going to go through show a little bit more about, we're going to go through a little bit more about when we use this and what the accounting looks like for with regard to calculating, in particular, bonds. So the discount on bonds and premium on bonds, and what the because this is one of those instances when we would use it. So we're going to go through one of those examples in a lecture video coming up. Thank you.